Hello, algebra, and here we go with the last lesson in Unit 3. Yes, I know it's a very short lesson, short unit, sorry. We've actually done this, kind of, back in the last unit, too. So this shouldn't be hard because we're just kind of building a little bit on something we've already done. So we're moving to inequalities, systems of inequalities. Now, solving equations versus solving inequalities, we're going to take a look at what some differences are. A solution to any equation or inequality is any ordered pair that makes the equation, inequality, or system true. That's just, we've been doing that for a long time. A solution is something that makes something else true. A solution to a system of equations, which is what we've been doing for the last 4 lessons, is found at the intersection of the two lines, which is why there is only one solution, typically, right? We know we have some special cases that we've talked about, but most of the time, two lines are going to intersect at one spot, so that's why there's one solution. A solution to a system of inequalities, though, is found in a region of the graph. Oops, let me write that a little bit better. A region of the graph created by the two lines, which is why there are infinitely many solutions. And you're going to see that when we graph these. And like with equations, we could graph them to solve them, but we could also do substitution elimination. With an inequality, we have to graph because it's a region. All right. How many regions were created when I had one linear inequality, which we did last unit? If you want to look at the notes, it's unit 2, lesson 10. We made 2 regions. The line split the graph into 2 separate spots. How many regions do you think we're going to have typically when we have 2 linear inequalities? A lot of people think 3. It's not 3. It's actually 4. So real quick example. The blue cuts that into 2. The green makes 2 more. So I've got 1, 2, 3, 4 regions. Okay. That's what we're going to be looking at. All right. So how many of those regions, of those 4 regions, represent the solutions to a system of inequalities? We're going to find the 1. There's only one region that will work and give you all the true ordered pairs. Okay, so let's take a look at how to do that. Find all solutions for each system of inequalities. So it goes back to graphing. We've done this. We've been doing this for a while. Now, it also, if you remember back when we did this in Unit 2, solid versus dotted. This first one is going to be dotted. And the second one is going to be solid. If you don't remember, equal to is solid, non-equal to is dotted. So the first one, 1/2 x. There's no y-intercept. So the y-intercept is 0. Slope is 1/2, so up 1, right 2. And I'm going to make a lot of these points. I'm going to go up 1, right 2 again, up 1, right 2. I can go down 1, left 2. The more points you put, usually the better. And there's my dotted line. Now, I recommend that you shade one at a time. Okay, so I'm going to do that real quick. I'm going to shade this one. I'm going to change the colors here. Actually, no, I'm going to go with red. And if you remember back from Unit 2, less than is below. So I'm going to shade below that line here. All right. Now, back in Unit 2, we were done. Now we have one more thing to do. We have to graph the second line. The second line is a weird line. X is greater than or equal to 1. So that's a vertical line. X is greater than or equal to 1. Well, 1 is on the x-axis, right? Or the the x-axis right there. And it's a vertical line right through 1. Now, I can't really shade above or below that line because it's straight up and down. If I go up, I'm still on the line. How do I go bigger than 1? Well, where are the numbers bigger than 1 on the x-axis? To the right. So I'm going to shade this to the right. And now I need to look at where are the regions shaded red and blue. Well, first of all, let's outline the 4 regions. So here's a region. Here's a region. Here's a region. And the last one is right here. So region 1, 2, 3, 4. The axes, the X and Y axis, those do not create the region. It's the two lines that create the regions. All right, so region 1 has no shading. So region 1 is not the solutions. Region 2 is only shaded blue, meaning the red line, the solutions for the first one are not there. So this one's out. Region 4 is only shaded red, which means the second one doesn't work there. So that one's out as well. Region 3 is where you get red and blue. Therefore, my solutions are in that region. So I make it very clear by shading it. I did a different color. You could use different colors if you want, or shade it darker with a pencil. Yeah. I'll give you some more tips if that doesn't work for you. All right. Last thing on this problem, it says give 2 solutions to this system. Well, there's a lot. You have a lot of answers here. You could put many, many, many answers. I'm going to give you one that's definitely on the graph, and then I'm going to give you one that's way off the graph to make the point. So 2 solutions. It's somewhere in that black region there. So that's, I don't know, +5, -3. So +5, -3 would be a solution because it's in that shaded region. Another one, kind of crazy, outlandish, way, way, way out there. So let's take 121. And anywhere down, right? 121 is way over here, and down, I don't know, 27. If I put 121 in for X and -27 in for Y, both of those inequalities will be true because that's a solution. All right. Next one. Go red and blue again. Before you do anything, solid or dotted. Luckily, these are both solid. Dotted is the hardest to remember. First one is already in slope-intercept form. That's good. Go down to 2. The slope is 1, so up 1, right 1. Up 1, right 1. And it's less than again, so below. So that was the one in red. We'll go blue now. Now, you might remember back from Unit 2, we got to get this one in slope-intercept form because the sign may flip, and it actually will here. You'll see that happen here. So -2y is greater than or equal to 4x plus 2. Divide by -2, and when you divide by negative with inequalities, you have to flip the sign. So less than or equal to -2x. 2 divided by -2 is -1. So -1, down to right 1, down to right 1. Solid line, so I can just draw it. And again, we're shading below because of the fact these flipped. And then where do the 2 lines, or where does the 2 shading overlap? I get to change colors. And they overlap in this region right here. Give 2 solutions. 0, -6 is 1. That's the switch to white here. 0, -6 is like right there. And then, I don't know, -2, -10. -2, -10 is going to be like way down here, which would be in that shaded region. Okay. A couple more on the back. A lot more space on this one. Go red and blue again. Again, both are going to be solid. So but they're both in standard form. So we got to do some work on this one. For the first one, subtract 3x. So 4y is greater than or equal to -3x minus 8. Divide by 4. I get y is greater than or equal to negative 3/4 x minus 2. Go ahead and graph it. Minus 2, down 3, right 4. I could go up 3 and left 4. And I shade this one above. Okay, that's the first one. Done. Second one, got to do the same thing. Subtract 6x, so negative 8y is greater than or equal to negative 6x minus 16. Divide by negative 8. Divided by negative, and that flips the sign, so less than or equal to. Negative 6 divided by negative 8 is positive 3/4. Negative 16 divided by negative 8 is positive 2. So up 3, right 4, or down 3, left 4. And because we flip the sign, we shade this one below. Where is the overlap? Make sure you're shading it darker or a different color, some way to make it very clear what you're saying the solutions are. Now there's a follow-up question, a little different than the last two. Last two I said, give me 2 solutions. Now I'm asking you, is 5-2 a solution? So I'm going to get rid of my shading real quick just so you can see it a little bit better. Is 5-2 a solution? So 5-2 is right here. Was that in that shaded region? Yes, it was. Now, if you don't know, if you're bad at plotting points, you could put 5 in for x and 2 in for y and see if it makes both inequalities true. It will here, but it's something you could do if you wanted. Now, at the beginning of the notes, I said something that you may not have caught. I said, typically, you get 3 regions. 4 regions. Typically. There's going to be a time when you don't. All right, so and this is going to happen here, just a little foreshadowing. First one, already in slope-intercept form. We'll go up to 4, up 3, right 2, down 3, left 2, down 3, left 2, down 3, left 2, and draw my line. Now you should have been saying to yourself, oh, wait, slow down, you're going too fast. I did that on purpose because I know students do that. What did I forget to do? This is a dotted line. Very easy to forget that. That is a dotted line. Okay. So is the second one. So the second one's also going to be dotted. Make sure you catch that. Above this line. Okay. Second one, you got to move it. So subtract 6x, negative 4y is greater than negative 6x plus 8. Divided by negative 4, flips the sign. Negative 6 divided by negative 4 is positive 3/2. 8 divided by negative 4 is negative 2. So negative 2, up 3, right 2, up 3, right 2. And what do you notice? Oh, let's shade below that one, right? What I notice here is that the lines are parallel, which creates not 4 regions, it creates 3, because those lines don't intersect. Because they don't intersect, it creates 3 regions, not 4. Now, how many of those regions represent solutions? Actually, in this one, none. There's no overlap. There are no solutions to this one. Okay? All the solutions to the first one are over here. All the solutions to the second one are over here. They don't overlap. Now, could there be solutions? Yes. This is not always the case. Let me change some things up, and I'll show you how there would be a solution. If this were opposite, and so was this. Okay, let's see what would happen. So let me go ahead and get rid of the shading. Let's reshade it with the change. So red, by the way, right now, just look. You don't need to erase anything and do this, but just kind of pay attention here. Less than for the red one. And when I solve that one again, what would happen would be sign starts this way, divide by a negative, it's going to flip it back to positive or greater than. The shade above, and these do overlap. See how they overlap right in the middle? That can happen as well. Okay, so that is linear systems of linear inequalities, and that is the conclusion of the unit.